Welcome everyone to today's webinar. I hope to talk a little bit about how computational notebooks can be a useful tool for teaching and research. And so from the previous polls, I saw that there were a good number of educators in higher education, secondary education, and also some enthusiasts who were just interested in working with notebooks. More than 50% of you have been creating your notebooks already, and a quarter of you are new to notebooks. So I'll try to strike the balance there. I'll talk about a few basics, and so the pros, please be patient. But then I will also not linger too much and move on to the more interesting aspect of what we hope to present today, the computational essays idea. So let's get started. I was hoping to talk briefly about what the Wolfram Notebook is for the newcomers, and also point to a few different venues where you can access and open and work with a Wolfram Notebook. Then I would like to move on to some of the features of the Wolfram Notebook that make it useful in teaching and research. I want to highlight some of the features that help in these two venues. And then finally, I want to end with one specific use of the notebook, that is to write the computational essay, which Stephen Wolfram talked about in his blog post, and which we hope you will find as a very useful mechanism in both presenting your content while teaching, or even to ask your students to submit their work in the form of computational essays to assess their understanding. Down the line also, maybe you might find it useful to have computational essays of certain kinds in recording your research, or just to talk about any topic that you find interesting. So the Wolfram Notebook is the original notebook that was pioneered by Wolfram almost 30 years back. So we had the notebook right from the beginning, although most of our original users used this as a programming interface. It has so many more features that can be explored. As you have probably, those of you who have been using notebooks are used to the fact that it's not just code. You can include text, graphics, so much more. And what it also provides access to is, being the programming interface for the Wolfram language, it provides access to this huge collection of algorithms through the built-in functions. We have 500 plus built-in functions in the Wolfram language, and also a great collection of high quality curated data through the built-in knowledge base that comes along with the Wolfram language. And then finally, notebooks are highly integrated and cross-platform. So you can create a notebook on your device and then go ahead and share it without worrying with other people who are able to open it in different Wolfram products. So for example, we have the well-known Mathematica, that's the desktop product that you can install on your system, and then you can open Wolfram Notebooks from within Mathematica. Or you can also have Wolfram Notebooks in the cloud. So we have the Wolfram Cloud, so you are able to look at notebooks in the browser across systems. And then, of course, we also have the Wolfram Player for, it's currently only for iOS devices, but if you're looking at it from the student's perspective, who like to look at things on their mobile devices, and if you're trying to distribute content, your lecture content, Wolfram Player is an option for looking at notebooks that you create. So as I just said, you can look at Wolfram Notebooks across different products. So let's take a look at the Wolfram Open Cloud here. So this is free access, and I will be sharing these links that I'm clicking and opening things from. So bear with me, you will have access to all this information. So we have this things to try notebook on the free cloud, the Wolfram Open Cloud, and I believe that is a very interesting point for newcomers to get started. You can just try out different things here in this things to try notebook and get the flavor of working with Wolfram Notebooks. Other than that, if you are unsure what sort of a product is useful for you, I mean, if you are an educator, you might be at one of our Wolfram sites, which has the Mathematica site license, and so you might have quick and easy access to Mathematica. If you're unsure about that, we have this page here where you can fill in your information, and it will tell you whether or not you have access to the Wolfram site license, and our customer service people would be more than happy to help you out with that. If you're looking for personal use, we suggest the Wolfram One subscription, which is a hybrid between desktop and cloud technology, where you can work with notebooks online in the cloud, but then also work on them offline using the Wolfram desktop. And then, of course, I showed the Wolfram Player. For more information about which Wolfram license, etc., you would like to use for your education related work, please feel free to visit our website here. So if you were going to introduce the Wolfram Notebook to your students, I wanted to list out some a quick list of features that might be useful in pointing out to your students that this is the way, this is the stuff that is available to you and you would be able to use if you were going to work with a Wolfram Notebook. If they have access to the desktop product, great. Otherwise, again, you can open up the a notebook in the cloud. So I was showing you the things to try notebook. Let me bring that up back here. You can work with that, or you can, just open up a new notebook from File, New Notebook here in the open cloud and be able to work with that. So, you have the standard stuff. You can have text here. And then you can, of course, have code here. And you can evaluate code. You can do other things like use the suggestion bar here, which for a newcomer, it gently introduces new things and says, oh, okay, by the way, we have some suggestions. Do you want to do this or that? Say do you want to look at the number of primes less than 8? Give little hints to ease people into using the Wolfram language in the notebook. So text, code, images, things like that. You can point out to your students that you have this hierarchical structure in the notebooks with the help of cells and cell brackets. So for example, if I were to make this of the style, say a section, I make this, I go in here and I go to the formatting menu here and I change this to a section. So I have a section here which is actually collapsible, and this keeps my document much more organized. So I can also have another section here. And again, I can change this to section. And so your student can now write new stuff in this and organize their work nicely, formatted nicely for presentation in class or just to submit their work. So this hierarchical structure of the document makes it very valuable for presentation, and it is also easily processed in a program itself, because the notebook itself is made with the Wolfram language. It's a Wolfram language expression and is amenable to programming. So this hierarchical structure helps with that. So yes, there is this intuitive programming interface. There's code assist, code completion. When you start typing in notebooks on the desktop product, little hints appear suggesting that is this the function you were trying to write, and it helps you along when you're not sure. There is also extensive documentation available, and let me pull up the in-product documentation center. So here you you can access information about all the different Wolfram language functions, and it is interactive itself. So you can go in here and play around with the code to better understand what it's doing. So, for example, I can go and edit and then run it and see, okay, this is what this particular function does. Okay, it creates a list of squares of numbers from 1 to 20. And so, of course, if I make it 100, it will create the squares for 1 to 100. So an interactive documentation. The function names are expressive themselves. So you have somewhat of an idea of what the function name might be. You go and search for it in the documentation center, and then our search will bring up that particular function that you need to use. The notebook can also handle natural language queries, so where you just type in an equal sign and then type in natural language some particular query, and then the notebook is able to interpret it. And we'll look at an example of that when we look at the computational essays. So these are the various features I hope that you are able to introduce to your students and get them excited and work on using Wolfram Notebooks. So moving from students to the educators themselves, the teachers, I know as teachers you're always looking out for technology that will help you in your classrooms to teach your students. I mean, from personal experience, I've worked with some amazing professors as TA, and I've always appreciated how they bring in technology to aid their students understand things better. So the Wolfram Notebooks we feel would help in teaching in many different ways. So starting out with the rich authoring environment that the Wolfram Notebook offers. So if you are looking to create computable documents, lesson plans, lectures, and handouts, quizzes, slides, and so on, you can use the Wolfram Notebook for that. In fact, this presentation that I'm giving, this slide deck was created in the Wolfram language using a special version of the Wolfram Notebooks as the presenter tool. So it just converts the notebook into a slideshow, and it gives associated features to for a presentation. So I have my notebook, but then I have also the useful things that I need to make it into a slideshow presentation. But let me show you a few examples of things that were created in Wolfram Notebooks. So this is a lesson on solids of revolution, the simplest possible notebook. So you can see how the styling options were applied to, nicely format the document with, titles, sections, text, images, which was created in the Wolfram language itself, mathematical equations, and so on. So an example of a handout that you might use in class, an example of quiz. Here's an example of a calculus quiz that was created with the Wolfram Notebook, where the student can provide the answers in the notebook itself. Let me see. Another example of lab exercise. So this is a lab exercise where we have this interactive document where the student can play around with this information here. So I think the question is to examine this model and then answer some questions here. So there is this interactive piece here that the student can play around with, and then you have to provide the answers in here. The sample of a lab exercise. Let me just quickly point out to the newcomers how easy it is to access these style definitions. So of course, you have the format menu, and I'm doing all this in the desktop product of Mathematica. A lot of these options are also available in Wolfram Desktop, or not the entire suite, but enough to help you work with notebooks in the Wolfram Cloud. It's pretty user-friendly. So you have the regular formatting menu to do format your stuff, but you also have the very advanced style sheet. So for example, I can go to the format menu and I can edit the style sheet for this notebook. As you can see, I have a very customized style sheet here, but I can make changes here. And for example, I can say I want all my text to have a background color of gray, which probably will make my slideshow hideous, but that is one option. So you see how like CSS for HTML, we have our style sheets, and you are able to use it like a pro to style your documents. Then we have different palettes here. Under palettes, we have the classroom assistant, which I hope you will find useful. Um, Let me bring it here to the center, where we have put together useful writing, formatting, templating tools. So you can just pick the template from here and then fill it out to create like a professionally typeset document. So that's all about writing and styling, then including text and graphics. So we have the graphics menu where you can use the drawing tools palette to actually create some graphics in your document itself, some basic shapes and styling of those shapes, etc. Or you can just use the Wolfram language itself to create graphics. And then work with it. They are interactive. You can resize it, restyle it. We can have 3D plots, and you can interact with it to make it look just right for your document. For images, we have the image editing interface. So for example, I can actually select this image here. Let's see, try to make it a little smaller. My little image editing toolbar is hiding underneath here, so I'm trying to bring it up so I can show it to you. Okay, let's do this. Let's bring this up to the top of the notebook so we can work with it better. Okay. Here is the image editing toolbar that I was talking about. And if I click on more, it opens up here. And so an interactive way to work with images. So here, for example, we have the interface to actually work with a number of our very advanced image processing functions that you can access from this menu itself and work with your images. So just another quick example of the ease of access to a lot of complicated stuff from within the Wolfram Notebook itself. Another element that we can bring in is the element of interactivity. So all explanations come to life if you can add some element of interactivity to it. So for example, if we were going to look at the effect of amplitude and frequency on a sine wave, yes, we can create a static plot. And then we can recreate that plot by changing the amplitude and frequency. So for example, here I have two variables and I keep changing them, and I would have to evaluate it over and over and again if I wanted to show my students, hey, look, if I change the amplitude, you will see a different sine wave with a different amplitude here. But it becomes so much easier if I create this as a manipulate. So now I can interactively show the effect of the amplitude. I can show the, this is, some people jokingly refer to this as proof by slider, where you just, you can move around the slider and now you can show your students how things actually work when you change the parameters. But the point I hope I'm trying to make here is that the ease with which this interactivity shows your students the effect of certain parameters on certain phenomenon very easily. The manipulate here is like the simplest of examples of interactivity that the notebooks can bring to you. I have included with the material in this presentation a more complicated example. This was created by one of our developers. So this is an interactive presentation on earthquakes, and this was created with the same idea of interactivity bringing more information and helping someone understand a particular phenomenon, or providing them the information of in a more interesting way. So hopefully this provides some inspiration for using notebooks. for your lessons. I'm going to go ahead and set my styling back so that I do not so that my presentation doesn't look all weird. So yes, so we talked about interactivity. The other point and I wanted to make is the quick access to these complex algorithms. So, nowadays we have access to a lot of data, and then I'm pretty sure in a lot of your classes you are trying to work with data, and there are certain things that you would like to try out. In the Wolfram language, we have built-in functions to do a lot of complex things so that you can focus on your lesson and you don't have to write code from scratch. So for example, just looking at data or exploring data, I have some example data here, and say I want to just look at a scatter plot of the data points in 2 dimensions. So one option would be to look at the feature space plot, which plots out these data points in a 2-dimensional space, and we can see very easily that how the colors cluster together, the greens on one end, the blues, the yellows, and the reds. Or if I actually want to use a well-established clustering algorithm to look at the data, I can do that with the help of one of the other built-in functions, find cluster, and I can even mention which particular algorithm to use. Or if I even want to quickly visualize the clusters, I can use yet another built-in function for that purpose. So I do not want to overwhelm you showing, here are all the different things you can do. I want to point you to the resources that are available from within the Wolfram Notebook itself to try out new things, which I hope will aid in your lesson. So access to algorithms, access to interactivity. Let's move on to access to data. So I mentioned that we have the built-in knowledge base. So for example, if you are, for you in your class, you're talking about the economics of South America and you want to look at the GDP for Brazil's GDP, we have the built-in country data available that you can invoke to get this particular information. And so, of course, it's not just for Brazil, but you can get it for all the different countries of South America. And while limit yourself to South America, you can make this interactive and get the information for all the different continents. So now you can explore together with your students a particular information to compare and visualize different kinds of data. Yet another example I have here is for chemical data. That is again another built-in data set. There are a huge number of examples here. If you look at the Wolfram documentation, you will see here we have this section here on different kinds of data. There's geographic data, engineering data, financial data, social, cultural, linguistic data, and I will leave it to you to explore these different things and see if there is something that you might find particularly useful for your class. And not just the built-in data, you have access to your own data. There are a whole number of different types of file formats that is supported in the Wolfram language. We can just see how many really. Right now, we support over 200 different file formats that can be imported. So if you want to import a CSV data file, here is an example of how you could do it. Or as we find sometimes useful nowadays, scraping data off the web. So here is an example of, say, importing images from a website. If you only want to look at the images from that website, so the import function can deal with it easily. All you have to do is give it the URL. So here's another example of just if you are trying to do some data analysis on the data scraped off those websites. So for example, I want to see what this particular page is really talking about, and I create a word cloud of all the text that I scrape off this website. So this is the World Wildlife page about red pandas. It's nice to see they are talking about red pandas. Things that immediately come to view is, okay, they are an endangered species. It talks about their habitats and so on. Two other useful resources I would like you to like to point out to you is the Wolfram data repository, where we have actually curated data from different resources. The difference being that here anyone can submit the data. If you have a nice data set, you can submit it to the Wolfram data repository, and once it is approved, it is up there available for anyone to use. And what's great about it is that it is ready in a computable format, so you can just get the data from the Wolfram data repository. It has been cleaned up, formatted, things that take forever when you're actually working with raw data. But when you download it from the data repository, it's good to go. You have it and you can just work with it. So here I have an example of downloading the global mean temperature from 1880 onwards. I downloaded from the Wolfram data repository, and then there is a quick example of actually working with that data. So I'll skip it in the interest of time right now, but you will have access to this notebook and you should be able to try out. So the notebook is a perfect tool for writing a computational essay. And here we have provided an example of a computational essay. So for example, say you have a lesson you're preparing on the Ring of Fire. The idea of the computational essay is that you will include text, and you would also include code that provides some useful information that augments the text. And so now what you have here is not just things that a student can read, but they have this code here which they can interact with, they can play around with, and hopefully the result of running that code will enhance their understanding. So for example, in this little piece about the Ring of Fire, I'm getting the earthquakes recorded between 2010 and now. Now, if your student is interested in getting earthquakes for a different period of time, it becomes so much easier for them to play around with the code and get this new data and look at it. So here I've tried to show how to combine both code and the built-in functions from the Wolfram language and the graphics resulting from running those functions to create this little bit about the Ring of Fire. Now, this same computational essay can also be a student report. For example, if your student was asked to write a report on the recent earthquakes in Hawaii, this would be a computational essay that they could come up with. So for example, here this student, this is a hypothetical student coming up, looking at the information of the Hawaii earthquakes, and then coming up with an observation that a whole bunch of smaller magnitude earthquakes seem to precede the large an earthquake of a high magnitude. So an example of a computational essay as student work. Then if a student was investigating a particular topic for doing some research on it, the computational essay could also be just his lab journal, where he gets information from the Wolfram language. And here are all examples of how you could use the Wolfram language in the notebook itself, the built-in database, the built-in entity informations from the Wolfram language to create a lab journal on the earthquake, the different volcanoes in Hawaii. So I wanted to point out some examples of computational essays from the Wolfram Summer School. So I chose a few from them, and all these students come from very diverse backgrounds. Not all of them had programming background, so they just came in, they picked a topic of their choice that they wanted to write about. So here is an example. This is a computational essay on money. And the idea of money, a very short discussion on the circulation of money in the network, someone from economics background, and they put together this computational essay with the idea that without much background on the topic itself, someone should be able to read this computational essay and have an understanding of what it is talking about. Here's another one about the Pappas graph. I believe this is by a sophomore or a freshman actually in college, who discusses this particular kind of a graph and its properties, and then a bunch of other graph theory related topics about this particular Pappas graph. Here is someone who comes from astrophysics background, they did a computational essay on exoplanets. And so they make use of the built-in entities, and they analyze the different kinds of information that is available, again, in the Wolfram language itself about exoplanets through the exoplanet data function. And they show how, things like Doppler spectroscopy or radial velocity method can be used to actually determine certain characteristics of these exoplanets. Another person, he is again also from a physics background. He explored earthquakes and Gutenberg-Richter's law. So the idea behind sharing these computational essays, and you will notice that I'm opening them up in the browser. So these essays, these notebooks, computational notebooks containing the essays have been deployed to the cloud, and so it is out there accessible to anyone, and it is still providing that interactivity and the rich data, the images, to talk about this particular topic. The idea behind sharing these essays with you is the hope that you will be able to use this form of narrative in your class too, and find it useful. So I would like to end with few tips, as Stephen Wolfram suggested, for writing these computational essays, things that you might want to keep in mind if you were going to use these for your students. Things like, keep the ratio between text and code, keep the code simple. While it is easy to get carried away and write really cool, complex code, the idea in the computational essay is that the code itself should add to the explanation. So someone reading the essay should be able to read the code and see, okay, I see what this is doing, even if they have no knowledge of the programming language itself. Try to explain what the code is doing, provide some annotations of the code, and then we have some technical suggestions that will help keep the code simple, so that people don't get lost in details of the code that they don't really want to know. They just want to look at the code and understand, oh, I see, this creates a timeline, a plot of some sort of financial data for some time period, and things like that. So I have included this in the notebook. Should you choose to use computational essays, I hope you will find these tips interesting. I will leave you with a list of few references that I hope you'll find useful. I'll go ahead and turn over the microphone to Dr. Kyle Keene here. We do want to actually hear about the interesting work he has been doing, the real life scenario where he has been using Wolfram Notebooks in his class.
Okay. Yeah, so I am a lecturer inside of the Department of Material Science and Engineering at MIT. One of my main charges is to bring computation into each aspect of the curriculum. We believe that coding and computation needs to be folded into the modern scientist training as much as mathematics and science communication. So we believe coding is a fundamental skill that each scientist needs to have. To accomplish that goal, at MIT in the physics class of the freshman year, we're bringing coding into the basic mechanics and the electricity and magnetism classes. So physics kind of 101 and 102. We call them 801 and 802. And then inside of my department, we are dealing with the sophomores who are coming into our department. Now they're specialized in material science, but they have very little coding experience. And so we have a class to get them jump started called Computational Methods for Material Science and Engineering. So those are the two classes that I currently teach that bring a lot of coding into them.
Thank you, Kyle. So what are the different ways in which you're using Wolfram Notebooks in these classes?
I do everything inside of Wolfram Notebooks, which is probably why I'm on the webinar. Wolfram Notebooks are my tool for preparing lectures. They're my tool for giving out readings before class. I run a flipped classroom, So they're the tools that I use to give interactive readings before class. And then when students show up in class, I use them to sometimes lecture with pre-built materials as well as do live coding in front of the students. I believe that students need to see failure and struggle modeled inside of the classroom. So I just open up a blank notebook and code. And then I will give them exams that include parts where they have to code and complete exercises that I've begun. And students work in small groups to create what you're calling computational essays. They create these computational narratives where they explain a topic, and their job is to weave mathematical logic, reasoning, and coding all simultaneously into an argument that convinces me that they understand a physical phenomenon.
Can you show us some examples of the notebooks? I'm pretty sure our attendees would love to look at these examples.
Absolutely. I would start with, so I prepared the story of how I started to use notebooks in the classroom. So the first thing that I did is I opened up a notebook and I solved a problem that I found interesting. So I wanted to teach students how to visualize a three-dimensional field. So in electricity and magnetism, students are often shown these type of two-dimensional diagrams. And so I show them how to code those diagrams so they can see this is connected to what they're learning in their textbook. And then I go on, and it's just a small bit more code, and you can get to a three-dimensional visualization. And then you realize that an electric field is not just a two-dimensional thing. It is, in fact, a three-dimensional thing, and you can look at it from different angles and get very different symmetries. So now I have a very interactive three-dimensional visualization where students can explore electric fields in a much more tangible and meaningful three-dimensional way. So here I look at the different planes, and if you cut along one of these planes, you see the standard visualization, but they can understand that as they rotate that, they'll see different symmetries and, hopefully start to think of electric fields as three-dimensional things. So now I have students not writing new code inside of this. This is for the freshman physics courses. So they're doing very minor edits on the code. This is much more using the three-dimensional visualization and showing them how to represent electric fields in a computer algebra system inside of code, a coding language. So I can jump to the next one unless you have any questions on that.
No, why not show us some of the examples of the computational narratives you referred to, or one before that?
Oh, okay, yeah, so after you create these notebooks where it's you as a teacher are learning how to code for yourself inside of a notebook and you share that with your students, sometimes you get really excited and you create really interactive things. So these become a bit more code than you would want your students to start to interact with. And if I come along here and I'm creating what's known as a binary phase diagram by doing a convex hole along the free energy curves. So this is kind of advanced material science, but this computational method is a fundamental thing that you need your students to understand in material science. And so I got a bit too excited and I spent many hours building out a tool that would help students understand this. So this is something that I wouldn't give the code, but I use notebooks to deliver this to my students so that they can understand what is normally shown as a sequence of images in their textbook. This lets me take that visualization a lot further and allows them to edit the underlying physics and see how it affects this binary phase diagram.
Yeah, I think one great example of what we were referring to earlier in the presentation is incorporating interactivity for better student understanding. And here you see a great example. And here Kyle is giving you live demo of how exactly it is so easy to create a slider with just that little function there, slider right at the bottom of his screen. You can see that he's just creating this, as we are talking, he's creating a simple slider in the notebook itself.
Right, so this is me programming inside of a notebook, and I'll create a slider that lets me dynamically change a value inside of my notebook. So this is not just a place to put static code. This is very living, breathing, computation. So the next stage after I get overly excited and build out things that are more advanced than I want my students to build is I step over into a full what's kind of called a scaffolded faded example. So inside of my notebook, I start to remove some content, and then I make that a space where students need to step in and fill in the missing parts. So I want them to learn how to code full narratives. So in order to do that, I write a full narrative, and then I remove some content, and then I ask them to finish it. So
Yeah, and I was just commenting, I would love to be in your class. It's so interesting, but it's amazing that like it's not just subject specific, you are also tricking them into learning coding while they are learning the content, the content from your specific, for this specific topic. So that's a great idea as well. Um, so Kyle,
and it's not even.
go ahead.
I was going to say, it's not even just tricking them to learn coding. We're actually doing research right now, collecting data. Our hypothesis is that you actually have increased learning outcomes for the context, for the physics, if you teach them physics through coding. So we're running some educational research studies right now on edX in order to determine whether or not adding this type of computational narrative actually increases learning outcomes within the subject that they're doing it in.
Right. Thanks, Kyle. In the interest of time, we'll move on to a little bit about the another way you have used notebooks is that in the cloud-based course. Could you quickly show us a little bit how you've used it in the Wolfram Notebooks in the MITx online learning course?
Right. So there's two ways that I currently use it inside of MITx, which is a variant of edX and similar to Moodle or Coursera. You can embed a simple iframe. So if I want to let my students code without having to worry about grading, then I can give them the cloud notebook directly inside of an iframe. So this is not just a widget that they're playing with. They can actually come into this notebook and write code for themselves and run that code. So I can give them examples of things such as creating a manipulate to study the different frequencies and what it means to increase or decrease the frequency of a periodic function, and they can come and get that same interactivity inside of the class. So in our Physics 101 and 102 courses, we have them create these interactives so that they can start to study the relationship between something as simple as sine of a frequency times x and looking at what changing that frequency does. The second way that we use notebooks inside of these online courses is using an LTI framework, which means
Yeah, it's unfortunate. I think we are losing Kyle a little bit all the way from India here. Maybe the connection is not that great, but I think what he was highlighting that these online learning platforms, they have their framework and you're able to use the Wolfram notebooks within that framework. So he was giving an example of that, of how he has used these notebooks in the MITx, for the MITx edX platform. We'll very quickly discuss a few questions. If you have something specific you would like to ask Kyle, or if there are any other questions, Jamie, we should be looking at. Is there something that you would like us to talk about?